211, we continue what we're doing with percents, but the difference is going to be, instead of saying like, what's 80% of this number, they're going to say if you have a certain percent increase or a certain percent decrease, what do you end up getting? So I want to start out just by saying, and put it in red for dramatic emphasis, and check the thickness. Yep. So, okay, so the percent change equals the change divided by the original. So that's something new. I don't think we did that last year. But if they say, you know, what's the percent increase of this thing to something else? What's the percent change? So if I were to take this here and say we have 15 grows to 40. So I don't know, my kid was 15 inches tall at birth. Totally making this up. Now my kid's 40 inches tall. What's the percent increase? So the change is going to be what?
15.
The change is neither 15 nor 40. It would be
It's 35.
close.
25.
25. So if I want that change, maybe I should actually show my work. So I'm going to say percent change equals the change divided by the original. So for the actual change, well, they started at 15, grew up to 40. So it's 40 minus 15 gives me the change. Or in other words, a 25 is how much my son's height has changed. Then if I divide that by the original, 15 inches at birth, because 40 inches at birth would just be wrong. Anyways, so 25, shouldn't have went there, sorry. But you get 1.6 repeating, yes?
Yes.
Or you could say 1 point might help to see it. ... So what percent increase is that? Go for it.
Would it be 166%?
Perfect. Or if you round, you probably should say 167. You move the decimal point 2 places, so you get 166.7% or 167%, 166.67. Along those lines somewhere. We okay for those? So that's that one. If we were to do the percent decrease, let's see what happens. So if we have a 12 drops to 3, so I want to do the change divided by the original. And the change is going to be 9. So 12 minus 3, so I have a 9. A lot of people won't show that step. But the original, is it the 3 or the 12? 12. So now we're going to get something that's less than 1, because 9 over 12 is less than 1. And we get a 0.75, which would be 75%. So I really should say it's a 75% decrease. And probably I should go back up to the one above it and say it's 166.7% increase. So in other words, if that was, say, my bank account, so I had $12, you know, maybe say 1,200 or 12,000 or something, it drops down to 3. I just had a 75% reduction. I lost 75% of what I started with. So then I get a new, or at least new mutual fund or something. But we okay on Roman numeral 1? Yeah. Cool. So that's going to be kind of a small part of it. The increase by a percent. So now this, I know we had a whole section on this last year. Increase by a percent. And for that, I'm going to say, first of all, you keep 100%. So this is huge. You know, you might want to try to draw some sort of emphasis to that line right there. But if you're going up by a certain percent, you take that percentage that it's increasing and you add it to 100%. Because what's happening is you're keeping the 100% of your original. You keep that 100%, but you're adding on a certain percentage of that to it. So iPhone sales are projected to increase by 20%. If you're watching the news at all, it's actually going down. But iPhone sales are projected to increase by 20%. If sales, if English is terrible, but if 57,000 were sold in Grand Rapids last year, how many are projected to be sold this year? So we have 2 ways of doing it. You could do this. And this is not doing this purple thing up above, so I'll switch to blue. But you could figure out, okay, percent times the original equals the new, or maybe we said percent times whole equals part. But you could figure out what is that 20%. So we put in 20% as 0.2, right? Then we'd say, all right, and we're starting out with 15,000. So 20% of 15,000 gives me 11,400. So it's supposed to go up by 20%. if 11,400 is 20%, that's how much it should go up, right? So if you want, exactly, if you want the total sales, then you have to take this and add it to that starting amount. And then you'd have 68,400. So in theory, if this is true, they're going to sell 68,400 phones next year. Yes? There's nothing wrong with that. The danger for someone that's kind of scattered like me is I could see myself getting this number, being like, done, ching, and then you get the answer wrong. What I like doing is this. I like doing this and then doing it all in one step. So when I do my percent times the original equals the new, instead of putting in 20%, I'm just going to right away put in, I'm going to put a little arrow and say 120%. I want to find, instead of figuring out 20% and then adding it to 100%, I just want to do it all in one step. How do I write 120% in my problem, though?
1.2.
Perfect. So that's 1.2, or you could do 1.20 if that helps you see it. But if I do that just times my original amount, right away I'm going to jump up to the 68,400. So you don't have to bother adding that original in. You kind of added the original in when you added in the 100%. So it's really totally up to you. I like way number 2 because it's faster. But if you prefer the first one, if that makes more sense, you think you're going to get it right, do it the first way. And then the very last part, basically it's the same sort of thing, but now if we're looking at a decrease by a percent. So in other words, if we're looking at something's going to lose a certain percentage. So the number of hot lunch eaters decreased by 40% when they switched away from Subway to whatever's giving us our subs now, and there's mass complaining. It was awful. Still is. We're getting robbed. It's not even less more. Okay, but if hot lunch eaters decreases by 40%, the first way you could figure out percent times the original, and if you love one way, you could even skip writing it the other way. But if we want to figure out it's decreasing by 40, well, let's figure out how much does it decrease. So 40% of my 127 eaters gets me down to, I'm going to round it up to 51 people. It's 50.8. But, so in other words, if it goes down by 40%, it's going down by 51. So then we do 127 minus 51, and that gives me 76. So 76 people still order hot lunch. So that's one way that's totally legit for doing it. The way that I like a little bit more, personally, is percent times original equals new. And I'm going to put this in red for dramatic emphasis. Lots of people, they put in a 0.4. But from 100. So it's 100%. Originally, we had 100% of people that were doing this. We took off 40%.
60%.
Yep, so what we're trying to figure out is what's the 60%? What's the percent that's still eating lunch? So 40% don't eat lunch anymore. How many are the 60% that do? So now I can put in a 0.60. My original is 127. Now with a little bit of rounding, I'll get that same 76 people. But the key, if you're going to do way number 2, is you're always asking what percent's left after you're decreasing by a percent. What percent's left? Figure out the percent that's left.